The 767 landing gear is hydraulically extended and retracted. The main gear doors are hydraulically operated. The nose gear doors are mechanically linked to the nose gear. They open, then close as the gear retracts. The center hydraulic system furnishes the hydraulic power for landing gear retraction and extension. Normally, the center hydraulic system also provides the operating pressure for the nose gear steering. Each main gear has 4 wheels on a dual-axle truck. The trucks are level on the ground, and they tilt when the aircraft is in flight. The tilt action provides most of the air-ground sensing for the 767. During gear retraction, the tilt condition is removed to allow the gear to fit in the wheel well. The nose gear has 2 wheels on a steerable strut. The nose gear retracts forward. The hydraulic brake system includes the normal brake system, the alternate brake system, and the brake accumulator. The normal brake system is powered by the right hydraulic system. The alternate brake system is powered by the center hydraulic system. If right hydraulic system pressure is low, the center hydraulic system automatically supplies pressure to the alternate brake system. If center and right hydraulic system pressure is low, center system reserve hydraulic fluid is provided exclusively to the alternate brake system and nose wheel steering. If normal and alternate brake hydraulic pressure is lost, a brake accumulator can provide several braking applications or parking brake application. Anti-skid operation is always available as long as normal electrical power is available. The right hydraulic system powered brake system, designated the normal brake system, is the system that is normally used. If the right hydraulic system fails, the alternate brake system, powered by the center hydraulic system, is automatically activated. There is no indication that the switchover from normal brakes to alternate brakes has occurred, other than by inference, because the right hydraulic system pressure light is on. An auto brake system is available for both takeoff and landing. This completes the overview. Both the main gear and the nose gear operate air-ground sensing systems. Most of the main gear provides air-ground sensing through the action of tilt sensors located on each main landing gear truck. Landing gear truck tilting causes proximity sensors to send air-ground signals to the airplane systems to signal air or ground status. The nose gear uses the extension and compression of the nose gear strut to operate an air-ground sensing system that controls the stall warning system and the ICAS master caution and master warning lights and associated aural sounds during the takeoff phase of flight. Should either of these air-ground sense systems fail, an ICAS advisory message of air-ground system or nose air-ground system is displayed. The landing gear lever normally controls the operation of the landing gear. If normal gear operation fails, a guarded momentary action alternate gear extension switch can be used to extend the gear. The landing gear lever has 3 positions: up, off, and down. On the ground, the gear lever is locked in the down position by a solenoid-operated lever lock. Accordingly, when on the ground, the landing gear lever lock override button is normally extended. The button is automatically retracted and the lock is released on liftoff as a function of the main gear air-ground sensing system. In non-normal situations, if the button remains extended after takeoff, pushing the landing gear lever lock override button allows moving the landing gear lever to the up position. In this non-normal situation, the gear trucks are tilted as a result of gear retraction into the gear wells. Normally after takeoff, both main gear tilt, thereby changing the air-ground sensing system to the air mode. This causes release of the landing gear lever lock. When the landing gear lever is pulled out and moved to the up position, the gear retraction sequence begins. First, an amber gear light illuminates to indicate gear disagreement with lever position. The main gear doors are hydraulically powered open to allow for gear retraction, then close after the gear is retracted. The nose gear doors are mechanically linked to the nose gear and open to allow for retraction, then close as the nose gear retracts. The door's light illuminates when the gear doors open, then extinguish when they close. Individual, nose, left and right gear down lights extinguish as the landing gear retracts. Automatic braking of the main wheels occurs during retraction. Snubbers arrest the rotation of the nose wheels. After the retraction sequence is complete, the landing gear lever is placed in the off position. This depressurizes the landing gear system. The main gear is then held in the retracted position by the locked door structure. The gear and doors disagree lights extinguish when the gear are up and locked. After gear retraction, the landing gear lever is moved to the off position to remove hydraulic pressure from the landing gear actuators. If any gear fails to retract and is not up and locked after the normal transit time, about 25 seconds, in addition to the illuminated gear light, an ICAS caution message of gear disagree displays and is accompanied by the 4-second caution beeper. Note: any gear that remains locked in the down position will have its green gear down light illuminated. Each individual gear uses dedicated down lock sensors to control the individual green landing gear down lights. The doors light and an ICAS advisory message of geared doors indicate any door that remains open after gear extension or retraction. Pulling the landing gear lever out and placing it in the down position starts the landing gear extension sequence. First, the gear light comes on when the lever and gear position disagree, then the gear doors unlock and open. Consequently, the doors light comes on. The gear is then powered to the down position. As each gear reaches the down and locked position, its green down light illuminates. When all gear are down and locked, the gear light extinguishes. The main gear doors are then sequenced to the close position. After the main gear doors close, the doors lights extinguish. The gear trucks are then hydraulically tilted to the flight position. If any gear is not locked down after the normal transit period, the gear light remains illuminated and an ICAS caution message of gear disagree is displayed. The absence of the illuminated green gear down light indicates which gear is not down and locked. The main gear are each considered down and locked when both the side brace and drag brace of that gear are down and locked. If either brace is not down and locked, the associated drag brace or side brace caution message will display. The non-normal procedures differ depending on which brace message is displayed. The alternate gear extension system serves as a backup system to the normal gear extension system. The alternate landing gear extension system uses an electric motor to trip the locking mechanism for each gear. When the locking mechanisms are tripped, each landing gear will free fall to the down-locked position, and the hydraulically operated gear doors will remain open. The system is activated through the alternate gear extension switch. The maximum speed for alternate gear extension is shown on a placard directly above the alternate gear extension switch. The guarded switch has a momentary down position. The doors fall open, and the gear then free falls to the down and locked position. The individual left, right, and nose gear down lights come on as the respective gear locks in position. After the gear down lights illuminate, selecting the landing gear lever to down extinguishes the gear light. Therefore, the doors light will be on for landing and taxi. The nose wheel steering system is powered by the center hydraulic system. Primary steering control is through a tiller located on the captain's side of the cockpit. The tiller can turn the nose wheel 65 degrees by rotating the tiller 360 degrees in the desired direction. A pointer on the nose wheel indicator scale indicates the selected turning angle and direction of turn. This frame shows the minimum pavement width that is required to make a 180-degree turn. The rudder pedals can also be used to turn the nose wheel steering, but only turn up to 7 degrees. Tiller operation, however, overrides rudder pedal input at any time. When the center hydraulic system fluid level is low, an automatic isolation valve will close to ensure the C1 pump can pressurize the steering system with below standpipe fluid quantity. This isolation valve can be manually operated by use of the reserve brakes and steering switch. We will discuss this feature in more depth with the reserve brakes description. The hydraulic brake system includes the normal brake system, the alternate brake system, and the brake accumulator. Anti-skid protection is available in all modes of braking. Auto brakes are available only with the normal brake system. The normal brakes are powered by the right hydraulic system. Normal brakes are available when the right hydraulic system is pressurized. The alternate brakes are powered by the center hydraulic system. Alternate brakes become operational when the normal brake system is not available, provided the center hydraulic system is pressurized. If hydraulic pressure to the right and center hydraulic systems is low, a brake source light illuminates to direct the flight crew to select the reserve brakes and steering switch. Pushing the switch isolates the C1 electric hydraulic pump in the center hydraulic system and supplies pressure exclusively to the alternate brake system and nose wheel steering system. The accumulator brakes are powered by accumulator pressure and use the normal system brake components. Accumulator brakes activate automatically when all other brake systems are not operating. In this situation, the brake source light will be illuminated. Brake pressure is indicated by a brake pressure gauge located on the first officer's instrument panel. Indicated pressure on this gauge close to 1000 psi indicates no remaining brake pressure. The transducers send wheel speed signals for each wheel to the anti-skid controller, which in turn reduces individual wheel brake pressure until the skidding has stopped. When a potential skid is detected, the controller signals the applicable valve to bleed off hydraulic pressure. This action prevents the wheel from skidding when maximum braking is required. The anti-skid system also prevents wheel lockup and hydroplaning and provides touchdown protection. When normal brakes are used, the individual wheel anti-skid protection is operational. When alternate or reserve brakes are used, the anti-skid protection is provided to laterally paired wheels, so that a skid of one wheel causes brake pressure to be released to both paired wheels until the skid is arrested. An amber anti-skid light on the overhead switch panel and an ICAS advisory message of anti-skid off indicates an anti-skid malfunction or power loss of the anti-skid system. Notice that no anti-skid on-off switch is provided for aircraft with this configuration. Some aircraft are equipped with an anti-skid switch on the overhead panel. This switch is normally on as shown, but if the switch is off, the amber off light comes on. The off light will also illuminate if the system is on, but the parking brake valve in the anti-skid return line fails to open after releasing the parking brake. Perform the appropriate non-normal procedure in this situation. Now click Next to answer some questions.